Hey guys, I am Deric. Welcome to my channel. In this video, I'm going to show you how to use financial calculator for the questions of time value of money. Before we start working on the questions, you will need to download the financial calculator from the App Store. Just search financial calculator, you will find it. After downloading it, just open it. That's what you will see. We will use TVM calculator for the calculation of time value of money. Inside TVM calculator, you may key in the figures in the empty space. If you want to get the answer, just press on the button. You can also change the compounding period here. First part, let's calculate the future value of a single amount. Jane places $800 in a savings account, paying 6% interest compounded annually. She wants to know how much money will be in the account at the end of 5 years. Let's analyze this question. $800 is the money that Jane is going to save, which means she is going to pay now. So, this is PV, and it would be negative 800. Paying money would be negative, receiving money will be positive. 6%, this is the annual interest rate, IY. 5 years, this is the period, N. To get the answer, you need to calculate the future value, FV. Now, turn to the financial calculator, set annually compounding, and set end mode. Then key in negative 800 for PV, the present value. Key in 6 for IY, the annual rate. Key in 5 for N, the period. Lastly, press FV, then you will get the answer. This amount of money will be in the account of Jane at the end of 5 years. Next, let's calculate the present value of a single amount. Mary wishes to find the present value of $1,700 that will be received 8 years from now. Mary's opportunity cost is 8%. This question means, after 8 years, Mary will receive $1,700. That means, $1,700 is FV. What you need to calculate is PV. Using financial calculator, set annually compounding, and set end mode. Then key in FV equals 1,700, N equals 8, IY equals 8, last step, press PV, you will get the answer. Negative PV means, this is the money that you will have to pay now. We have just discussed the first pattern of cash flow, which is single amount. Now let's look at the second pattern, annuities. Annuity is a series of equally spaced cash flows, occurring over a specified number of period. That means, same amount of cash flows will be repeating. Annuities can be either inflows or outflows. There are two types of annuities. The first type is ordinary annuity. An ordinary annuity has cash flows that occur at the end of each period. The key word is, the end of each period. The second type, annuity due. An annuity due has cash flows that occur at the beginning of each period. The key word is, the beginning of each period. An annuity due will always be greater than an equivalent ordinary annuity, because interest will be compounded for an additional period. Let's take an example. If you buy a bond, you will receive equal semi-annual coupon interest payments over the life of the bond. Equal semi-annual coupon interest payments are annuity. Another example, if you borrow money to buy a house or a car, you will have to pay a stream of equal payments. Loan payments are annuity as well. Tracy is choosing which of the two annuities to receive. Both are 5-year $1,000 annuities. Annuity A is an ordinary annuity, and Annuity B is an annuity due. Tracy has listed the cash flows for both annuities as shown here. For Annuity A, the ordinary annuity, it means Tracy will receive $1,000 at the end of each year. But for Annuity B, the annuity due, it means Tracy will receive $1,000 at the beginning of each year. To show this is the cash flow received at beginning of year 1, we will write the cash flow at year 0, which is 1 year forward. Similarly, cash flow for beginning of year 2, we will write it at year 1. Note that, the amount of both annuities is $5,000. But in fact, they have different values. Let's put it into calculation. Tracy wishes to determine how much money she will have at the end of 5 years if she chooses Annuity A, the ordinary annuity, and it earns 7% annually. Using financial calculator, set annually compounding, and set end mode. Then key in PMT equals -1000, N equals 5, IY equals 7. Last step, press FV, you will get the answer. Positive FV means this is the money that you will receive after 5 years. If we slightly modify the question, Tracy now wishes to calculate the future value of an annuity due for Annuity B. Recall that Annuity B is a 5-year annuity with the first annuity beginning immediately. Using financial calculator, set annually compounding, and set beginning mode. Then key in PMT equals -1000, N equals 5, IY equals 7. Last step, press FV, you will get the answer. Under beginning mode, the FV is higher, which means Tracy will receive more money for taking an annuity due. Let's look at another question. Jason wants to determine the most he should pay to purchase a particular annuity. The annuity consists of cash flows of $700 at the end of each year for 5 years. The required return is 8%. So to determine the most he should pay, that means how much he should pay now, that is, PV. Using financial calculator, set annually compounding, and set end mode. Then key in PMT equals 700, N equals 5, IY equals 8. Last step, press PV, you will get the answer. Negative PV means this is the money that Jason has to pay now. Next question, for the same scenario, Jason wants to determine the most he should pay to purchase a particular annuity, which consists of cash flows of $700 at the beginning of each year for 5 years. The required return is 8%. Using financial calculator, set annually compounding, and set beginning mode. Then key in PMT equals 700, N equals 5, IY equals 8. Last step, press PV, you will get the answer. This is the money that Jason has to pay now. Under beginning mode, the PV is higher, which means Jason will have to pay more money for purchasing an annuity due. Next we have a special form of annuity, which is called a perpetuity. Perpetuity is an annuity which continues forever, that is, infinite life, providing continual annual cash flow. To get the PV of a perpetuity, we take PMT over interest rate. For example, how much would you have to deposit today in order to withdraw $1,000 each year forever, if you can earn 8% on your deposit? Just apply the formula, PV equals to $1,000 over 0.08, then you will get $12,500. It means, now you have to deposit $12,500, so that you will receive $1,000 every year until forever. Next, the third pattern of cash flow is a mixed stream. For this type of calculation, you will need to use the E.A.R NPV calculator. Let's look at this question. What is the most you should pay in order to receive the following mixed stream of cash flows over the next 5 years? The cash flows from year 1 to year 5 are shown in the question, and the required return is 9%. Using financial calculator, key in discount rate equals 9%, CF0 equals 0, CF1 to CF5 will be the cash flows from year 1 to year 5. Last step, press calculate, then you will get the net present value. NPV is the present value of a mixed stream. Next, this is an example of calculating the future value of a mixed stream. How much will you accumulate if you receive the following mixed stream of cash flows over the next 5 years? The cash flows from year 1 to year 5 are shown in the question, and the required return is 8%. To calculate the future value of a mixed stream, we need to go through 2 steps. First step is to get the NPV, second step is to convert the NPV to future value. Using financial calculator, step 1, key in discount rate equals 8%, CF0 equals 0, CF1 to CF5 will be the cash flows from year 1 to year 5. Then press calculate, you will get the NPV. After this, go to step 2, key in PV, that is the NPV that you just calculated, put it in negative. Then, IY equals 8%, N equals 5. Last step, press FV, you will get the answer. This is the future value of a mixed stream. Next is an example of calculating the present value of deferred annuity. You expect to receive $20,000 per year at the end of year 4, 5, 6, 7, and 8 from an investment. How much should you invest now if you require a 20% rate of return? This question means you are not going to receive any money from year 1 to year 3. Using financial calculator, key in IY equals 20%, CF0 equals 0, CF1 to CF3 equals 0, CF4 to CF8 equals 20,000. Last step, press calculate, you will get the NPV. This is the present value of a deferred annuity. Next, let's look at the calculation of future value of deferred annuity. You expect to receive $20,000 per year at the end of year 2, 3, 4, 5, and 6 from an investment. How much would you receive at the end of year 8 if the discount rate is 20%? To calculate the future value of a deferred annuity, we need to go through 2 steps. First step is to get the NPV, second step is to convert the NPV to future value. Using financial calculator, step 1, key in discount rate equals 20%, CF0 equals 0, CF1 equals 0, CF2 to CF6 equals 20,000. Then press calculate, you will get the NPV. After this, go to step 2, key in PV, that is the NPV that you just calculated, put it in negative. Then, IY equals 20%, N equals 8. Last step, press FV, you will get the answer. This is the future value of a deferred annuity. Next part, we are going to talk about the effective annual rate, E.A.R. Which one is a better loan? 8% compounded annually or 7.85% compounded quarterly? It seems to be better to take the quarterly loan, as it is cheaper. However, these nominal or quoted interest rates cannot be compared, because they do not have the same number of compounding periods per year. So the solution is, we need to calculate the effective annual rate. Effective annual rate is calculated based on this formula. 1 plus quoted rate over compounding period, to the power of compounding period, minus 1. So, to find the effective annual rate for the quarterly loan, according to the formula, you will get 8.08%. Therefore, the quarterly loan is more expensive than the 8% loan with annual compounding. To compare the nominal and effective annual rates of interest, the nominal interest rate is the stated or contractual rate of interest, charged by a lender or promised by a borrower. This is the interest rate that banks show us. However, the effective interest rate is the rate actually paid or earned. This is usually not shown by the bank, and we have to calculate it on our own. Compounding more frequently than once a year results in a higher effective interest rate, because you are paying or earning interest on interest more frequently. In general, the effective rate is greater than the nominal rate whenever compounding occurs more than once per year. The more frequently the interest is compounded, the more the effective rate of interest will increase. Let's put it into calculation. If you decide to invest $1,000 and earned 6%, how much would you earn after 3 years with interest compounded quarterly? Using financial calculator, set quarterly compounding and set end mode. Then key in PV equals negative 1,000, IY equals 6%, N equals 3 times 4 is equal to 12. Last step, press FV, you will get the answer. Another example. If you decide to invest $1,000 and earned 6%, how much would you earn after 3 years with interest compounded monthly? Using financial calculator, now set monthly compounding and set end mode. Then key in PV equals negative 1,000, IY equals 6%, N equals 3 times 12 is equal to 36. Last step, press FV, you will get the answer. Alright, that's all for this video. Thanks for watching. See you in the next one. Bye.